A game programmer sets a specification that the game must take no longer than 1 second to load online. Use the given data to determine the natural tolerance limits as well as the leeway of the game loading process. This is an extension of a previous video where we looked at a software developer and the sample size of 7. So the software developer took a sample of 7 different load times each day and then found the average of each of those load times and then took the average of those averages. So the mean of the means is what we see here, the 0.0835. And then we also looked at the range of each of the data points in each day. So in other words, if we had a 0 load time and a 0.05 load time, then the range is 0.05. And then we took an average of all of those ranges. So that is denoted with a capital R with the bar over it. So average of the ranges. So we can use some of this information to build a natural tolerance limit. And so I'm going to do that in yellow. Let's just code this. The natural tolerance limit. Well, that's going to be the mean of the means, x bar bar, plus or minus 3 times the mean of the ranges divided by d sub 2. And the d sub 2 is this number, this one. And that corresponds to a sample size of 7, and we use it in the use it from the D4 column. So that's just the way it's denoted. Why the number 3? Well, the number 3 is because we're talking about 3 standard deviations from the mean, and if you get far from anything farther than that, it's very unlikely that you will get a point farther than that, because about 99.7% of the data lies within plus or minus 3 standard deviations. So that's why we use the number 3. Okay, let's plug the numbers in. We get 0.0835 plus or minus 3 times mean of the ranges 0.3915 over d sub 2, 1.924, and I'm just going to stick with the plus on this one. Well, I'll write out the plus or minus first of all. 0.0835 plus or minus, and then all of this business is equal to 0.6104, rounding. So plus or minus. So if I were to minus the 0.6104, I'd get into a negative number, and you're not going to load a game in a negative amount of time. So this makes sense in other applications, but not in this one because we're talking about time, so we're not going to go negative. But I will add those, and so I've got an upper natural limit of 0.6939 seconds. And a lower would be 0, of course, 0 up to this 0.6939 seconds. So that looks pretty good. If we want to stay less than 1 second, it looks good there. But another measure of how capable a process is just how far away it is from the mean, how far away the specification is from the mean. And depending on what kind of data you have from your process. So we look at the z value. I will do this in red, the leeway. So the z value equals the upper or lower spec. I'm just going to deal with the upper spec because, again, we're not going to go in the negative time frame. So the upper spec minus mean of the means all over the mean of the ranges divided by this d sub 2 again, this number. So plugging all of that in, we get z equals 1, that's the upper specification, 1 second, minus the mean of the means, 0.0835, over mean of the ranges, 0.3915, divided by d sub 2, which is 1.924. And in case you're typing all of this into your calculator at once, let me just do this, because otherwise the calculator is good at order of operations, and if you don't specify that this whole thing is in the denominator, it's going to give you the wrong answer. Okay, so let's calculate, evaluate all of that, and we get 4.50. That's our z. Well, anytime we have an absolute value of z, because if you're going in the on the lower spec number, you would have a negative number, but anytime you have an absolute value of z that's greater than 3, that's good. That's said to be capable because of this 99.7% of the data business, and that's why being within plus or minus 3 standard deviations, that's why that 3 number comes up again. So we can also look at what you may have heard in process control is what is the sigma on this? So what is the sigma capability? So 4.5, and we subtract from that this number 3, and we say that we have a 1.5 leeway. So that's what it was asking for. What was the leeway? So that's answering that question. And you could also say it has a 4.5 sigma capability. So 6 sigma is what a lot of companies go for, but don't confuse sigma with the leeway. Those are 2 different numbers, but of course they are obtained from this one number of 4.5. So our leeway, again, just to answer this question, our leeway is 1.5.